kids! It's nice to see you again. Welcome to another session of Learning Mathematics. I am Ma'am Aika, and I am your grade 10 mathematics teacher. So for today's videos, we will discuss about combinations. This is the lesson for week 3, quarter 3 in mathematics grade 10. Our objectives for today is to solve the combination of objects. But before we go on solving, let's have a review first. Combination is the number of ways of selecting from a set when the order or arrangement is not important. Order arrangement does not matter. Also, permutation refers to the different possible arrangements of a set of objects where order matters. So always remember the two, combination and permutation. Now, with that in mind, let's have another review activity. I want you to show a thumbs up if you agree with the statement or thumbs down if you disagree with the statement. I will give you 5 seconds to answer. Let's start. Statement 1. Combination does not consider the arrangement of members in a group. Agree or disagree? Go. And the correct answer is, good job, agree. Combination does not consider the arrangement of members in a group. Let's try statement 2. Combination of n objects taken r at a time is equal to permutation of n objects taken r at a time divided by r factorial. Do you agree or disagree? Go. And the answer is, good job! It's agree. Remember how we derived the formula for combination? Yes, this is our formula. Combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial. Take note that n factorial over the quantity n minus r factorial came from the permutation formula. Now let's try the next statement. In the problem, in how many ways can a committee consisting of 4 members be formed from 8 people? The value of n is 4. Do you agree or disagree that n is 4? Go. And the answer is, good job! It's disagree. And here is not 4, but it's 8. It's the total number of objects that we have. And for our last statement, if we have a set of 5 distinct objects, then the number of ways of choosing 2 elements of this set is the same as the number of ways of choosing 3 elements. Is it the same, choosing 2 and choosing 3 out of 5 distinct objects? Agree or disagree? Go. The correct answer here is, good job! It's agree. But before I show you the solution on this statement, let me know if you get 4 out of 4. Because if you did, very good, mathletes. But if not, it's okay. Don't worry. We will have more discussion about combinations. Ay ka, husay, mathletes! Now, let's go back to that statement 4. And let's prove that the combination of 5 objects taken 2 at a time is equal to the combination of 5 objects taken 3 at a time. So let's use the formula to solve the problem. Formula, combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial. So let's solve first the first one, where n is equal to 5 and r equals 2. This is 5 factorial over 2 factorial times the quantity 5 minus 2 factorial. That is 5 factorial over 2 factorial. If you solve this one, you will get the combination of 5 objects taken 2 at a time, which is equal to 10. Now let's try the other one. What if our n is 5, but r is 3? Again, substitute it to our formula. Combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial. And we have 5 factorial over 3 factorial times the quantity 5 minus 3 factorial. This is also the same as 5 factorial over 3 factorial 2 factorial. When you expand and solve or use your calculator, you'll be able to get 10. So since we have them both, you can see here that C, n equals 5, r equals 2, and C, n equals 5, r equals 3, have the same answer, 10. This is actually what we call the symmetry of combinations. So the combination of 5 taken 2 at a time is equal to combination of 5 taken 3 at a time. So in a general form, it is the combination of n objects taken r at a time is equal to the combination of n objects taken n minus r at a time. Symmetry. Now, let's learn more about combinations. And let's take a look at this first example. Example 1. From a population of 20 households, in how many ways can a researcher select a sample size of 10? You have to ask yourself this. Is the order or arrangement of objects important or not? Is it? Good job, it's not. Therefore, we will use combination for this problem. Now, identify your n and r. Our n is 20 and r is 10. So since we know that this is a combination problem and we have the given, we can now use the formula n factorial over r factorial times the quantity n minus r factorial. Reminder, keep on writing so that you will always remember your formula. So substitute these values. We have combination of 20 objects taken 10 at a time is equal to 20 factorial divided by 10 factorial times the quantity 20 minus 10 factorial. That gives us 20 factorial over 10 factorial, 10 factorial. Wow, the numbers are quite big. So you can actually use your calculators, or if you don't have, help me with this. Let's simplify the expanded form of your permutation. So we have to cancel 10 factorial on numerator and denominator. We also have here 10 times 2, which is 20. We also have 18, 6 times 3. We also have there 16 divided by 8, which is 2. But since we have here a factor of 4, we could also divide it by 2. That's why we have here 8, 2. Next. 15. 15 is divisible by 5, so there is still 3. And so we divide the 9 by 3, and we get another 3 here. 14 is the same as 7 times 2, so we cancel. And what else do we have here? 12 divided by 3 is 4. So the remaining numbers here for the combination is 19 times 17 times 13 times 4 times 11. So the combination of 20 objects taken 10 at a time is 184,756 ways. The researcher has 184,756 ways of selecting a sample size of 10 out of 20 households. Wow, that many, right? I know, right? Let's try this example too. In a 10-item mathematics problem-solving test, how many ways can you select 4 problems to solve? Again, ask yourself, is the order or arrangement important or not? Very good. The order of getting or choosing a problem on the test is not important. Therefore, this is a combination problem. And then identify your N and R. N is 10 and R is 4. And now use it to your formula. The combination of N objects taken R at a time is equal to N factorial over R factorial times the quantity N minus R factorial. Substitute N equals 10 and R equals 4, and we get 10 factorial over 4 factorial times the quantity 10 minus 4 factorial. Solving, we have 10 factorial over 4 factorial, 6 factorial. And again, use your calculator or expand and simplify, and you will be able to get here 10 times 3 times 7. The answer is there are 210 ways to select 4 problems out of the 10-item problem in a math test. There are a lot of ways to choose from, right? 210. Remember symmetry of combinations? So if we are getting the combination of 10 items taking 4 items at a time, it must be equal to the combination of 10 items taking 6 at a time. So, if there are 210 ways to select 4 problems, there are also 210 ways to select 6 problems out of 10. That's the beauty of the symmetry of combinations. You don't have to solve the second one. Let's try the third example. How many different sets of 5 cards can be formed from a standard deck of 52 cards? That's a lot. Again, ask yourself, is the order or arrangement important or not? Very good. The order is not important. You just simply have to select 5. So N there is 52 and R equals 5. So in solving, you have here your formula N factorial over R factorial times the quantity N minus R factorial. Substitute 52 to N and 5 to R. So you have 52 factorial over 5 factorial times the quantity 52 minus 5 factorial. Oh, the numbers are big. But again, let's simplify if you do not have your calculators with you. So we have there 52 times 51 times 50 times 49 times 48 times 47 factorial. I'd stop there because there is a 47 factorial on the denominator. Simply expand your 5 factorial. That's 5 times 4 times 3 times 2 times 1. And we can actually simplify 50 by 50, which is 10, and 10 divided by 2, which is 5. What else? 48. If we divide 48 by 4, it's 12. And 12 divided by 3 is 4. So the numbers to multiply are 52, 51, 5, 49, and 4. The numbers are quite big, so yeah, use your calculator. As you can see here, there are 2,598,960 ways to select 5 out of 52 cards. Imagine that. The bigger your N, the smaller your R, there's the big chances or more choices of outcomes that we have. Now, let's check for more problems. Problem 1. In a 10-item mathematics problem-solving test, how many ways can you select at least 8 problems to solve? So again, ask yourself, Is the order or arrangement of objects important or not? Very good. Order does not matter. So this is a combination problem. But did you notice the word at least? When we speak of at least, it means that the minimum problem is 8. So we have here 3 cases. Case 1 is to select 8 problems. Case 2 is to select 9 problems. And case 3 to select 10 problems. With these cases, you have to solve them all and add together to get the sum. So for case number 1, our r is equal to 8. We have now your formula n factorial over r factorial times the quantity n minus r factorial. Substitute, we have 10 factorial over 8 factorial times the quantity 10 minus 8 factorial. That is 10 factorial over 8 factorial 2 factorial. Simplify. And the combination for 10 problems taking 8 at a time is equal to 45. Now, let's try case number 2. How about if we select 9 problems? R is equal to 9 and substitute it to your formula. Again, n is still 10. So, 10 factorial over 9 factorial times the quantity 10 minus 9 factorial. We have there 10 factorial divided by 9 factorial, 1 factorial. And simplifying, we now have the combination of 10 problems selecting 9 at a time is equal to 10. And now let's go to case number 3. Now, what if we have to select them all? Remember, when n is equal to r, we want to select the 10 problems at once. Therefore, your combination is equal to 1. We now have solution for case 1, 2, and 3. So to answer the problem, we now have to add them all.
So, the answer to our problem is 56. There are 56 ways to select at least 8 out of 10 problems in a mathematics problem-solving test.
So please remember that word at least. It is also applicable if you see the word at most. It's just the opposite. Okay. Now let's try this. How many polygons can possibly be formed from 6 distinct points on a plane, no 3 of which are collinear? Polygons. We wanted polygons. So in this one, again, check. Is the order or arrangement of points important or not? Remember naming triangles? The arrangement do not matter. So in this case, this is still not. It's a combination problem, yes. So let's proceed in solving. But we wanted polygons. It did not specify how many sides for the polygons. So we will have here 4 cases. Case 1, for the number of triangles formed. Case 2, for the number of quadrilaterals formed. Case 3, for the number of pentagons formed. And case 4, for the number of hexagons formed. So let's solve it one at a time. Case 1 plus case 2 plus case 3 plus case 4 will be the number of polygons, which is our n. So you have it here, written simply in combination. And let's solve. The combination of 6 objects taken 3 at a time is written in this way. So simplify, you will get here 5 times 4, and that is 20. The combination of 6 objects taken 4 at a time is this. And don't forget to simplify, and you will get 5 times 3, which is 15. For the third case, if we wanted to select the pentagon, so that leads us to this kind of solution. And this is simply 6. And of course, if we wanted to select 6 points out of 6, then there's only one possible way to do that. So you have 1. So 6 plus 1 is 7 plus 15 plus 20. Therefore, our n is 42. There are 42 possible polygons formed with 6 distinct points that none of which are collinear. Dami, right? With the different examples presented to you, we can say that life is full of choices, okay? There are a lot of choices around us. We just have to be open to those choices. And when we are making our choice, please make sure to choose what will make you happy, that will not harm yourself nor other people. That's the most important one. Not just to harm yourself, but also not harming the people around you. And I guess at this time, we are now ready for the 30 seconds challenge. So prepare your paper and pen and let's try to answer the problems. Shake, 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 and let's start with the first one. It is the arrangement of objects where order does not matter. Go. And the answer here is good job. It's combination. This is the word for the video. We always say about this combination, combination, combination. Does not matter. Order does not matter. Order does not matter. Now for our second and final question, I want you to pay attention to this problem. Number 2. To find the total number of polygons that can be formed from 7 distinct and non-collinear points, Joy answered this. Combination of 7 points taken 3 at a time is equal to 7 factorial over 4 factorial 3 factorial. 7 times 6 times 5 times 4 factorial over 4 factorial
times 3 times 2 times 1
is equal to 35. There are 35 different polygons according to Joy. Is she correct? I'll give you 30 seconds to think about it. Go. So, mathletes, is she correct? Yes or no? Well, actually, she's not. Though the solution is actually correct, but this solution is only for the number of triangles formed. What about the others? We also have quadrilateral, pentagon, hexagon, and heptagon. So, you need to solve not just one problem for the combination of getting triangles, but also for the other polygons that I have mentioned. Understand? So, mathletes, did you get 2 out of 2 questions? Ay ka, yan naman pala. So, math is quite confusing at times, but when we think about the steps on how to solve the problem, we will be able to answer them all. Wow, time flies so fast. And before we bid goodbye, always remember that in learning mathematics, ay ka yako, ay ka yamo, and together we say, ay ka yan natin to. Thank you, mathletes, for staying with me all throughout the video. I hope you learned something and see you next time. Goodbye!